In this video, I'll be explaining to you what remote sensing is and what GIS is in very simple terms so that even if this is the first time you are coming across these technologies, you will be able to walk away with some useful information. And in addition, I'll also be providing some examples of applications of remote sensing and GIS, and we'll be discussing the kinds of remote sensing technologies we currently have. We will also be touch basing some of the key terms associated with GIS towards the end. I have separated the video into chapters so that in case you are interested in specific topic, you can hop onto those sections, and all the links mentioned in this video will be included in the description section below. So that out of the way, let's get started. Hey guys, welcome back to my channel and Happy New Year. If you guys are new here, hi there, this is Mikey. I'm a PhD student at UC Berkeley working at the intersections of remote sensing, forestry, and data science. And in this channel, I'll be posting daily videos on topics ranging from drones, LiDAR, trees, maps, data analysis, visualization, machine learning, and everything else in between. The idea is to make concepts associated with physical geography and data science simple enough so that more people can apply it. So yeah, this channel is gonna be a bridge between spatial science and data science. So if you're into any of this, make sure to subscribe. Okay, let's start with remote sensing. When we first hear remote sensing, what are those things that we associate it with? Well, satellites and obviously NASA, right? That's why here I got this makeshift drawing representing a satellite drawing and also the confused Earth. But remote sensing is much more than just satellites, which we'll be getting into in a bit. So what is remote sensing? For answering that, let's split the words here. The first part is remote. This relates to something that is not physically touching the object of our interest. And the second part, sensing, can be interpreted as the feeling we get when we sense an object. So by feeling in this case, we mean the information that we are extracting, which can be something like a physical property of the object. And this is exactly what remote sensing stands for. It is a science of measuring or obtaining information of an object without making any physical contact. I repeat, remote sensing is a science of measuring or obtaining information of an object without making any physical contact. So without making any physical contact, that's the important part here. And the term was coined in early 1950s, and nowadays it's a major branch of study within the realm of physical geography. Now let's consider our day-to-day behavior and see whether we can relate it to the concept we just discussed. For instance, imagine you are hanging out at your backyard and working on some assignment in your laptop. So are you here remotely sensing any data? If you consider you're typing on the keyboard, it is not remotely sensing the data as you are making physical contact here. This is the same when we take the case of lab work where we are performing experiments and physically measuring things. Whereas imagine here you got bored and you decide to relax and just look around and observe the trees and birds around the corner. This can be considered as remote sensing, as here you're not making any physical contact with the object of interest. As I mentioned before, even though satellite-based imagery is the most popular topic related to remote sensing doesn't have to be always done from outer space. Nowadays, drones are another widely used platform for performing remote sensing. Also note that the platform carrying the sensor don't always have to be in the air. The laser scanning technology now that's being used in the autonomous car is also an example of remote sensing. So is the X-rays you take at the hospital. In case of the laser scanning technology, which is also known as LiDAR, we are able to detect objects and even create three-dimensional models of them. I'll be creating a playlist entirely on LiDAR remote sensing in the coming days, and the link will be included in the description section in case you are interested in exploring more on the topic. Among all the examples we have just mentioned, note that there is always a sensor that collects the data, and there will be a platform for having the sensor, whether it be a satellite or drone or car. And based on how the object under focus is illuminated, remote sensing can be classified into two categories, active and passive remote sensing. In case of passive sensors such as drones taking photos here, it depends on external energy for illumination. They actually measure the reflected sunlight emitted from the sun. Meanwhile, active sensors, they have their own source of energy for illumination, and LiDAR is a classic example of this. Another relatable example can be when you take a photo on your phone at night using flash. Here you use your own source of light for illuminating the target, right? So this is also an example. Now if you ask me whether active remote sensing or passive remote sensing is better, it totally depends on your particular situation. In general, active remote sensing can be found to be more dependable than passive remote sensing methodologies. As you can imagine, we can't depend on satellite imagery based on remote sensing during the nighttime, as we need the sun's energy for illumination. Also, the sensors are heavily affected by things like clouds and aerosols. However, active remote sensors are mostly more expensive than passive remote sensing technologies, and it's not always possible to acquire such data for large-scale or recurring studies. I think this is a very broad topic and deserves a video of its own. Let me know in the comment section if you guys would like me to make an in-depth video on this in the future. Well, we live in a world overloaded with data, and apart from the personal level data collection happening, there are also a lot of other global scale active and passive sensors that are orbiting the globe and collecting data of the Earth 24/7. Even though we won't be going in a lot of detail here, I would like to introduce you to some other major types of remote sensing. All these classifications are primarily based on the electromagnetic spectrum, the thing we all learned as we were kids. Yeah, the same thing where the visible light falls towards the center. Without doubt, the most common and widely available remotely sensed data is through optical remote sensing technologies. Optical remote sensing makes use of visible, near-infrared and short-wave infrared sensors for capturing images. Another common remote sensing method is the LiDAR, which stands for light detection and ranging, and this is an active sensor where the target is illuminated with laser light and the reflection is measured with a sensor. Then we have thermal remote sensing, which uses the infrared portion of the spectrum and measures emitted thermal energy. And another remote sensing technology that is gaining popularity is the microwave remote sensing, which draws inferences based on the emitted microwave energy. And once again, based on the source of energy, all these remote sensing technologies can be further grouped into either active or passive sensors. Now, after realizing that we have all these data, so what's next? A lot of us are oftentimes left with a bunch of question marks inside our head, and it's totally normal. Based on our interests and research question, we need to decide what kind of remote sensing data to choose from. For instance, a person working on the agricultural sector might find microwave remote sensing very useful, as it helps quantify properties such as soil moisture. Same with optical remote sensing technologies, which will allow you to monitor plant health and estimate crop yield. On the other hand, a person working in the urban designing might be more fascinated with LiDAR, as this can be used to develop something like 3D models of the buildings or bridges. Irrespective of the field you are in, I bet you can find some applications of remote sensing in your everyday work. We just scratched the surface here. There is even more. We also have something called sonar, which utilizes sound energy and make observations based on how sound waves bounce off various objects. Same way, we also have radar, which we all know is something used by police for speed enforcement. But once again, make sure not to get overwhelmed with all this vast multitude of data and information. I know this might be a bit too much for an intro video, but I just wanted to give you an idea of what all you can do using remote sensing. Nowadays, we just see the success stories of people coming up with all these amazing discoveries using the data available, but we should also remember that all these are achievable for us as well. The thing that is holding a lot of people back is not the lack of information, but the surplus of information. Imagine you see something like satellite used to detect forest fires in Amazon or something like that. And now if you want to try doing the same, you are generally forced to read an entire textbook or numerous research articles. All these long-winded research explanations are for sure required, but we also need to make sure that the tools are easily accessible to the common public and are easily understandable so that more people can get involved. And that's a major motto of this channel. So If you agree with my ideology, hit that like button and make sure to subscribe.